Now to number 8, the relationship between hybrid vigor and inbreeding depression is. So if we think of hybrid vigor, we are obviously talking about breed heterozygosity. So this is heterozygosity. And then when we think of inbreeding, where you're thinking of increased homozygosity across the genome. So these are clearly two opposites from each other. So the correct answer is B. It's not negligible. When you have increased homozygosity, you tend to see less hybrid vigor. It's definitely not strongly positive, and it's not estimated by the relationship coefficient, and it does not have a parameter space from 0 to 1. So heterozygosity and homozygosity are opposites in general. Moving on to number 9, we have our calving rate, and we have our Angus calving rate of 0.88 and Brahman calving rate of 0.8. We then have crossbred cows with Brahman sires and Angus dams at 0.81 and Angus sires with Brahman dams of 0.91. So we're calculating the heterosis. Remember, heterosis is the difference in the averages between the parental genotype or the parental breeds and the crossbred breeds. So we have our crossbred breeds at 0.81 and 0.91. So we take the average of that. And then we have our parent breeds of 0.88 and 0.8. And we also take the average of that. And the difference between the two gives us 0.02, which is the correct answer. So once again, heterosis, you calculate heterosis by calculating the difference between the average of the parental breeds and the crossbred breeds. Number 10, we have half Hampshire, half Rambouillet males mated to 3/4 Hampshire, 1/4 Rambouillet females. And so we're wanting to give the breed proportion of the offsprings, kind of like we did in our crossbreeding lab. That's the first step. So you can do that by calculating the average. The average of each breed. So we have a half Hamp and then 3/4 Hamp. Divide that by 2. And then we have half Rambouillet and 1/4 Rambouillet and divide that by 2. So we're taking the average of each breed that are in both parents, which gives us 5/8 and 3/8. So the correct answer is C. Moving on to number 11, the Roning locus in equine. So we're looking for the correct answer. We know that it doesn't decrease with age. We know that it does alter all types of backgrounds, as you can see in this one. This is a bay roan. It is not just a sorrel roan. It is not linked to the C locus. It's linked to the extension locus. And it really isn't progressive with age. While they are born without roaning, when they shed their full coat, they're basically as roaned as what they'll be for the majority of their life. Sometimes you'll see variations between summer and winter coat, but we don't see a great increase in roaning as they age like you do see in gray. So the correct answer is C. The R genotype in horses keeps the face color normal. That is, the face is not roaned, and this horse right here is a good example of that. You can see that it basically stops on the cheekbone and their face does not stay roan, while in gray horses, their face does in fact turn gray. Moving on to number 12, a ram has an inbreeding coefficient of 0.125, so f of x, that's our inbreeding coefficient. And we know that the inbreeding coefficient is the gene given at a random, chosen at a random, is in his DNA will be homozygous due to inbreeding with a probability of 0.125. That is basically the definition of inbreeding coefficient, so A is correct. His sire and dam were relational. Well, yes, they were relational because they had offspring, but that does not make them inbred, so it is not B, so we can cross out E. But if an animal does have an inbreeding coefficient, we know that his parents were related in some shape or form. So C is also correct, so D is the correct answer. Number 13, which of the following is true about curly calf syndrome? A is the correct answer. Their legs are fixed, their joints are fixed, and their legs are extremely twisted. It is not only seen in Charolais cattle, we oftentimes seen in Angus cattle. There is a genetic test available, as you can see down here, but you cannot be an affected animal. If an animal is born and it has curly calf syndrome, yes, it's affected, but you're not going to get it genetically tested because the animal will eventually pass away because it is a recessive lethal genetic abnormality. And then the last one is calves often have no bone marrow. That is not the case. That's actually in marble bone disease. So the correct answer is A, calves' legs are twisted and their joints are fixed.